Solving a system of equations by substitution. We're going to use substitution when a variable is already isolated or can easily be isolated in one step. Notice that in this top equation, y is all by itself. That means it's isolated. And what does y equal? Well, y equals the expression negative 2x plus 1. So what I'm going to do is I'm going to substitute that expression in for that isolated variable. So to do this, we're going to rewrite the second equation. But where I see that y, I'm just going to put a parenthesis. And in that parenthesis, I'm going to substitute what y equals, 2x plus 1. Let's distribute the negative 2. Negative times a negative is a positive 4x minus 2, and bring everything else down. I'm going to combine like terms, so 2x and 4x, when I add them together, I get 6x. I'm going to add 2 to the other side. That will cancel on the left, so I'm left with 6x equals 6. Divide both sides by 6, and x equals 1. So what I know is that when I solve a system of equations, I'm looking for an intersection point. I know that the x value of the intersection point is 1. Now I have to find the y value. I can find the y value by plugging in what I know to either equation. But it's going to be easier to plug into the one that you have boxed. So y equals negative 2, well, I know a value for x. So instead of x, I'm going to write the value of 1 plus 1. Now I just have to simplify. That's negative 2 plus 1, therefore y equals negative 1. So my solution is the point. We're going to write it as a point, 1, negative 1. Let's try a second problem. Like I said before, we're going to use substitution when a variable is already isolated or when it's easy to isolate. So notice this x right here. It does not have a coefficient, so it's going to be easy to get that by itself. So if I was going to manipulate this equation, I could add 2y to move it to the other side. And this equation is x, that will cancel, equals 2y plus 13. Now it is isolated. This equation right here and this equation right here are the same equations. All right, so again, our goal. Let's find a point of intersection. With this isolated variable x, I'm going to box what it is equal to, the expression. Then I'm going to substitute in for x. So let's go to that first equation, and we're going to substitute in for x. So let's rewrite that equation. 5, instead of x, I'm putting a parentheses, plus 5y equals 20. In that parentheses, I'm going to put what I boxed, the expression 2y plus 13. Well, now let's solve. Distribute 5, so I get 10y plus 65 plus 5y equals 20. Let's combine our like terms. Even though they're not side by side, we can add in any order, which is a commutative property. So I have 15y plus 65 equals 20. Subtract 65 to the other side so that it cancels on the left. And on the right, I have negative 45. Divide both sides by 15. Therefore, y equals negative 3. So my y value is negative 3. To find the x value, I can plug into this equation, or this equation, and I always choose the one that I have boxed. X equals 2. Well, I know the value of y is negative 3 plus 13. So x equals negative 6 plus 13, and x equals 7. So my solution is a point of intersection at the point 7, negative 3. Substitution. We use substitution when a variable is already isolated or can easily be isolated in one step.